Everybody. Today we're going to talk about volume of different figures. We're going to go through and take a look at prism, cylinder, cone, a sphere, and a pyramid. Even though there's different shapes that we'll be taking a look at, it's important to know that volume is base times height. Whatever the base of your figure is, you're going to multiply that by the height. So keep in mind, the base is what makes it two-dimensional, a triangle, a square, a rectangle, a circle. The height is what makes it three-dimensional. So yes, we're going to go through different formulas, but all of them, volume is base times height. Take whatever the area of your base is and you multiply it by your height because that's what makes it three-dimensional. So let's get into some different formulas. So for a prism, I'm just going to be generic about it and say volume is base times height. So we'll be taking a look at different prisms. Might be a triangular prism, just some different things that we're taking a look at. But our formula is volume equals base times height. Cylinder, I'm going to start with base times height also. Except for a cylinder, the base is a circle. So I'm going to say pi r squared times the height. So the big B, which is your base, that's the area of your base. So for a cylinder, my base is a circle. So that's why I have pi r squared, because my base is a circle. A cone, volume equals 1/3 base times height. The base is a circle again. So another way of writing this, I also can write pi r squared h. So pi r squared h, and then divided by 3. So these two formulas mean the same thing. 1/3 base times height. The base of a cone is a circle. That's where I got pi r squared from. So this multiplying by a third is the same as dividing by 3. So these two formulas are synonymous with each other. A sphere, think like a basketball is what I think of when I think of a sphere. So the formula for a sphere is 4 pi r to the third divided by 3. So 4 pi r to the third divided by 3, that's for a sphere. And then a pyramid, volume equals base times height divided by 3. So whatever the base of it is, we're going to divide that by 3. So these are your formulas. We got a prism, a cylinder, a cone, a sphere, and a pyramid. We're going to go through and we're going to use these. Again, our basic formula is base times height for volume. It's just trying to figure out what the base is. So let's get into some examples. Volume of regular figures. Find the volume of the following figures below and show all your work. First, I'm going to recognize that this is a triangular prism. So I'm going to put that over here to the side. Triangular prism. And my base is a triangle. Base is a triangle. Since my base is a triangle, I know that it's going to be base times height, but my base is a triangle. So that's 1/2 base times height. So I know that my base is a triangle, and that is 1/2 base times height. So this is how I got my formula. So I know it's base times height. My base is a triangle. So the base is 1/2 base times height. That's the area for a triangle. And then I'm going to multiply it by the height. So we're going to take our numbers and we're going to substitute it in. Now you kind of got to imagine that this is laying on the side here. So I see that my bottom triangle, the length of it, if this right here is 5, then this section down here is 5 as well. And I can see that my height is 1.5 because that's the perpendicular section that's right here. That's 1.5. So the numbers that I'm plugging in, 1/2 base times height. So I got that from, this is 5 up here. So if that's 5, then this down here at the bottom is also 5. And then I got my height from 1.5. And the height of the whole thing that makes it three-dimensional is 4. So this right here makes it 4. You can type all that into some sort of graphing tool, Desmos, whatever floats your boat. I got 15. And it's important to put our measurements, our units. So this is yards cubed. So that's number one. So it asks us to find the volume of this figure. It's a triangular prism. The base is a triangle. That helped me figure out that it's 1/2 base times height. We substitute our numbers in, and we got 15 yards cubed. So 15 cubic yards. Letter B. Okay. So this is a pyramid. So let's label that somewhere. This is a pyramid. And again, I can see my base is a triangle. So my formula for this, so it's going to be base times height, and it's a pyramid. But if I slide down just a little bit, this is base times height divided by 3. So base times height divided by 3. So my base is a triangle. So that's going to give me the 1/2 base times height times the height. And then I need to divide the whole thing by 3. So my base is a triangle. That's 1/2 base times height times the height. And then since it's a pyramid, I need to divide the whole thing by 3. So we took the base times height. We incorporated what the base of this specific shape is to get my formula. Now it's just a matter of substituting what goes in where into my problem. So I see that my base here is the triangle. So I'm going to pull out the numbers that I need. So this is going to give me 3 times 4. So those are the numbers down here at the bottom. I got my base and my height. And then my height is 5. So that's where I'm getting, that's where I'm getting this 5 right here from. So I'm using the 3 and the 4. So that's what I'm using, the 3 and the 4. That's my base and the height. And then this is making it 3-dimensional. So that's going to be 5. All divided by 3. Make sure when you type this in that you do 1/2 times 3 times 4 times 5. Get that number and divide it all by 3. A little cleaner way to write it, if you want to do 3 times 4 and then divide it by 2, then multiply by 5, then divide by 3. Just make sure you're typing this into Desmos correctly. You should get your volume is 10 cubic miles. So that's our answer. 10 miles cubed. All right, so that's a pyramid. Moving on. C. All right, hopefully you recognize that this is a cone. So think ice cream cone. So hopefully you recognize this is a cone. And the base of a cone is a circle. So base is a circle. So just identifying shapes and things like that, you don't have to do this. Just making sure we remember our different shapes and things that we have going on here. So this is a cone. So volume for a cone, if I slide down for just a minute, it says we're doing pi r squared h divided by 3. So pi r squared h divided by 3. That's the formula that we're using. So this gives me pi r squared h divided by 3. So it's just a matter of substituting what goes where into our formula. Pi stays pi. My radius up here, so the diameter is 2. This whole distance across is 2. This formula calls for the radius. So I take half that distance. My radius is 1. The height is 3. So I see that right here. The height of my cone is 3. And I'm going to divide that by 3. Type all that into Desmos, and we get pi. So it gives me pi kilometers cubed. So there is a pi button in Desmos. If you wanted to type in 3.14, it will be rounded just a little bit. But if you type this in, it should give you pi back out. All right, D. This is a cylinder. So hopefully you said that. So this is a cylinder. And the base is a circle. Okay. So our formula for cylinder is up there at the top. It says pi r squared h. So pi r squared h. So we're going to write that down. Always a good idea, whatever formula or expression, whatever you're working with, go ahead and write that down first. That way you can just look at the problem and substitute the correct numbers into the correct spot. So this is going to give me pi stays pi. My radius, again, they're giving us the diameter. We don't want to know what the diameter is. We want to know what the radius is. So my radius is 2. And the height for this problem is 3. So this was laying on the side, but that's okay. My height is 3. Type all that in. You should get roughly this amount. And my units are cubed because we're working with volume. So those are a few examples that we went through. We took a look at prisms, cylinders, cones. There was no spheres in this one, but we did have a pyramid, okay? So if you did have a sphere, you would use the formula 4 pi r to the third divided by 3. So we are going to take a look at a couple of word problems down here using the formulas. So volume is base times height. So as long as you remember that, you should be good to go. You just got to recognize what the base of each of your shapes are. You buy 2 cylindrical calendars with different dimensions. Candle A has a diameter of 4 inches and a height of 8 inches. Candle B has a diameter of 6 and a height of 5. Which candle contains more wax? So I'm going to do candle A, figure out what that is. And then I'm going to do candle B and figure out what that is. My formula for both of these, since they're both cylindrical calendars, is going to be pi r squared h because they're both cylinders. So pi r squared h. Pi r squared h. All right, let's see what we got going for the first one. Candle A has a diameter of 4. I don't want to know the diameter. I want to know the radius. So my radius is 2. And the height is 8 inches. The second one, candle B has a diameter of 6. Again, I don't want to know what the diameter is. We need a radius, which is 3. So my radius is 3. And it says the height is 5. We type this into Desmos or some sort of graphing tool. So again, step 1, we wrote the formula down, recognize what formula you need, substitute the numbers into the formula, and make sure you're substituting in the radius and not the diameter. So when I plug this into Desmos, I got 100.48. And when I type the second one into Desmos, I got 141. So the question says, which candle contains more wax? Definitely candle B. So candle B has more wax. It's bigger, it's larger. So candle B has a height of 5 and diameter of 3, so that's going to hold more than candle A. So the answer to letter E is candle B. And the last one. Okay, there we go. If one guppy requires 5 liters of water to live happily, what is the maximum number of guppies that should be kept in this aquarium? So I have an aquarium here. And all right, so this is a prism. So we're doing base times height. And since this is a rectangular prism, my base is a rectangle. So my formula is length times width times height. So all volume is base times height, but my bottom part is going to be length times width because it's a rectangle, and then you multiply that by the height. Now, the commutative property works for multiplication and addition, so it doesn't matter the order in which I multiply these numbers. So it doesn't matter if I want to do 40 times 30 times 30 or 30 times 30 times 40. So the order doesn't matter because we're multiplying all of these out anyway. So I got 36,000 cubic centimeters. Now the question says, what is the maximum number of guppies that should be kept in this aquarium? I see liters in the problem. So we're going to need to go from liters to centimeters. So this isn't like a frequent conversion that you use all the time. So I will go ahead and give that to you. 1 liter equals 1,000 cubic centimeters. So again, this isn't a common conversion that you use all the time. So 1 liter equals 1,000 cubic centimeters. So I need to divide my answer by 1,000. So that's going to give me 36 liters. So why are we converting? Because this is a centimeter, and in the problem it says 1 guppy requires 5 liters. So I need to make sure my whole problem is in the same units. Now all I have to do is take this 36 liters, divide by 5 liters, and I got 7.2. So it wants to know what's the maximum number of guppies that should be kept in this aquarium. 7 guppies. So you're not going to keep 0.2 guppies. So the maximum number that we can keep are 7. And I did want to label that this is a rectangular prism. All right. So we've gone through, we did some different examples with prisms, cylinders, cones. We didn't have any spheres, but pyramids. And a pyramid was in here. So just make sure you remember that volume is base times height. Recognize what your base is and multiply it by your height, and you should be good to go.